All right, so in this video, we're going to talk about one property of logarithms, and then we're going to be solving exponential equations using logarithms. So the property that we need to be able to use logs to solve other equations is an exponent property like the one on the board here. So log base b of a, and you have something to the power of c. Um, if, if the number at the end has a power, you can bring the power out front. So if you notice here, the only difference between the first expression here and the one that is equal to is the fact that the exponent of c just moved to the front. It's no longer an exponent. It is now just a regular number. It's not superscript anymore. And so the logarithm helps us get exponents out of the top and down as a regular number. So in this case, log base 3 of 12 to the second power up here, that was here, is now the same as just bringing the 2 out front. And so now it's 2 times log base 3 of 12. And now you can use your calculator kind of to solve that. Not until we know what a common log is in the next slide, but this is kind of the whole basis of how we can use logarithms to help solve exponential equations, because they help us get the exponents out of the top. They help us get them down to like the regular level. And so this one, log base 10 of 5, again, if there is an exponent on this number, you can bring it out and it means the same thing. So this is the same thing as x times log base 10 of 5. And that might not seem like it helps us a lot right now, but it really does. All right, so that's a property we're going to use here in a little bit. But let's go over something that we're going to need to know because of how your calculator works. So something called the common logarithm or the common log is just a logarithm with a base of 10. Okay, so an example of a common log is log base 10 of anything. So the log base 10 portion is called a common log. So I said take the common log of 100. That would mean I'm asking you 10 to what power is 100, and so that's going to be 2. All right, we call it common log because in your calculator, you're only going to see the button labeled log. You're not going to see a base. You're not going to see a little number after logarithm like you do here for 10. So common log is just understood that number down there is a 10. So if you don't see a number down there, you can just assume it's 10. And the common log is what we're going to continue to use a lot of because that's the only button we really have in the calculator. We cannot type in, there is a way to do it, but right now you cannot type in anything that has a number down here other than a 10 because the only button we have in the calculator is log base 10. So if you wanted to figure out what log base 3 of 9 is, right now you would have to know that this is 3 to the power of 2 is equal to 9. So the answer would be 2. There's no way to do it on the calculator. And so again, it's written without a subscript, and because there's no subscript base written there, you can just assume it's a 10. All right, and we're going to be using this really often. Let me just take my calculator out here, show you what that looks like. Okay, so on your calculator, you can see on the left side here, you've got a couple options. So on the left side, you'll see logarithm. You'll see the log button, log, and that is the common log. So that is log base 10. So for example, here, let's clear this off. If I wanted to, I don't know, find the value of log base 10 of 150. Well, 10 to the power of 2 is 100, and 10 to the power of 3 is 1,000. So it should be somewhere between the numbers 2 and 3. Sorry, I'm having some trouble here getting this off the screen. Okay, so if I do log, it's automatically a base 10. So if I do log of 150, this should tell me 2 point something. Let's hope it does. 2.17. Okay, so again, that log button just means automatically it's a base of 2. And how we're going to use these, let's go back here. Okay, and so we're going to use that log button on our calculator to help us solve these exponential equations. So let's go full screen. Enter full screen. There we go. The common log is going to be used. So the first thing to do is, it's going to be hard to understand what this means without seeing an example. So I'm going to kind of rush through this, go to the example, and then it might make more sense. One is you're going to move everything away from the variable first. So if the variable is on the right side, you're going to move as much stuff to the left as you can, or vice versa. Second thing is you're going to take the common log of both sides, and we're doing that to help get the exponent out. So come up with a hypothetical example here. Say we got this, okay? Our exponent is on the right side, it's up here as a power. So the first thing I want to do is I want to get rid of as much stuff from the right side as I can. Okay, I cannot multiply 2 times 3 together to get the number 6 because that would be doing order of operations out of order. Order of operations says do the exponent first, then do the multiplication. So I can't just multiply the 2 in. So what I'm going to do is I'm going to get rid of the 2 by dividing both sides by 2. And that's going to get me a 5. And on this side, it's going to give me a 3 to the power of x. Okay, so that was doing the first step. That was moving everything away from the variable first. I can't move the 3 away because the power of x is connected to the 3 right now. So I have to find a way to unconnect the x from the 3 so that I can solve for x. And the way to do that is to use the common log. So what I'm going to do is I'm going to take the common log of both sides, log base 10, and take the log of this side. And that might not look like it does much. It looks like it overcomplicates things. But on the left side, log of 5 is just some number. And you can just type it in the calculator and figure out what number that is. So this is just a number on the left side. And on the right side, we have log base 3, or log base 10, because it's a common log. Log of 3. So like we just talked about, we can take the power of x and we can bring it down out of the power because that's a property that we just learned for logs. So right now I have a log of 5 on the left side. Again, that is just some number. I don't know what it is, but it's just a number on the left side. There's no variables on the left side right now. On the right side, I can bring this power of x down and put it in front of the log. That was one of the properties of logarithms, and that's kind of why I use it. And now we have log 5 on the left side. Again, that's just a number. And then on the right side, we have x times log of 3, and log of 3 is also just a number. So if I wanted to solve for x, all I have to do is divide both sides by the number that's with x, which is log of 3. And so when I divide both sides by a log of 3, I get my answer right there on the left side. So I would just type that in the calculator. So let's do that now. Let's open up the calculator, and let's type that in. So we just need to find out what log 5 divided by log 3 is. Okay, and that's our answer. We do have to round it. So we don't have an exact answer. This is rounded. So we can just round to 2 decimal places and say that x is equal to 1.46. Okay, and so if I tested that out on the calculator, right, 2 times 3 to the power of 2 times 3 to the power of 1.46, it should be as really close to 10. You can see I rounded that, so it's really close. If I didn't round it as much, let's do 3 to the power of, and let's not round it that much, 1.464973. You can see it gets closer and closer to 10. So it does equal to 10, so I checked that out. I plugged it in for x, and I made sure that it works for that equation. So here's 2 examples. First thing I want to do, I want to get everything away from where my power of x is. So my x is on the left side in this case. So I'm going to take this 8, and I'm going to move this 8 to the other side. All right, and then on the right side, I get a 125 because I have 117 plus 8. I get 125 on the right side. Now you might know what x is equal to in this case because you know that 5 to the power of 3 should equal 125. If you didn't, we can solve this using logarithms. So if I, at this point, take the log of both sides. All right, I have log of 5 to the power of x, but because it's to the power of x, I now can bring that x and write it out front. And on this side, I just have log of 125, which I do not know the value of right now, but I can find it. It's just a number. Then I divide both sides by log of 5, and we've got our answer over here. We just need to use the calculator to find it. Log of 125 divided by log of 5, if I did it in the calculator, would give me the number 3. And so that would be my solution. All right, last one over here on the right side. We need to get everything away from where my variable is at. So I have 3 to the power of 2x. This 4 is hanging out front. Let's get rid of that first. So I have 3 to the power of 2x is equal to 25. Now you might think, I got 2 up there with my x. That doesn't really change much. I'm still going to take the logarithm of both sides, so do log on both sides. Okay, now I have a log of 3, and my property tells me if I have a 2x as an exponent that I can bring it out front. It means the same thing. And on the right side, I just have log of 25. All right, now I'm going to do the same step I did in this first example where I divide off my whatever's with x. So right now it's log of 3. All right, so I could go ahead and figure out, let's go ahead and figure out what that number is on the right side. Log 25 divided by log 3. Log 25 divided by log 3. 2.9299. 2.9299. And that's estimated. You could go out some more decimal places if you wanted to. But what do we have left on the left side? We have a 2x on the left side. Because we got rid of our log 3 here, and we still have the 2x left. And so our last step to solve for x is to divide both sides by 2. And if you can, just leave this number in your calculator and just click divide by 2. Hit enter. That way we didn't have to round it until the end. Okay. So now my answer would be x equals 1.46. All right. So that's how you're going to solve some exponential equations using logarithms. And a couple of examples here, kind of how you would solve some of the compounding interest questions. All right, the first thing we're going to do here on the left side, we're going to go ahead and divide off our 100. Divide off our 100. 50,000 divided by 100 should be 500. And on the right side, we have 1 plus 0.05 to the t. Okay, and you could, in this next step, you could combine those together. You could add 1 plus 0.05. It is 1.05. Okay, and now I have something to the power of a variable, and now is where I want to go ahead and take the log of both sides. So I'm going to take the log of the left side, log of the right side. On this right side, now that I've done the logarithm of a number and it has an exponent, I can bring that exponent out front. All right, now that I have t out front, all I have to do is I have to divide off this number, which log of 1.05 is just a number. So I'm going to divide both sides by that number. And I'm going to figure out what that equals. So what is log of 500 divided by log of 1.05? Let's find out. Log of 500 divided by log of 1.05. And we get 127. Wow, that's a lot. So 127. So t equals. So if you're good at understanding compounding interest questions, that would mean in this case, that would mean if I had $100 and I put that in an account that was making 5% every year, it would take me 127 years in order to get to $50,000. All right. And that's going to be it for this video. We won't go over this example.